Probability of B greater than 0. The conditional probability of A given that B has already happened. Okay. Is defined by happened is defined by probability of A by B. This is the notation of conditional probability of A given that B has already happened, and this definition is probability of A intersection B divided by probability of B. For any two events A and B with probability of B greater than 0, the conditional probability of A given that V has already happened, this event B has already happened, is defined by this probability A by B equals to probability of A intersection B divided by probability of B. For example, suppose we are tossing two coins, then and it is given that the first toss, uh, it is given that the first toss is head. Okay, then what is the probability of getting the second toss also head or second toss tail? Okay, so on event the probability of one event will be given, that is the already happened event, and then you have to find the probability of another event. That is the concept of conditional probability. Okay, so similarly you can define probability of B by A. This equals to probability of A intersection B divided by probability of A. So from here we can write the multiplication rule of probability of A intersection B. Probability of A intersection B. That is probability of A intersection B. This equals to, so if you see the first probability of A by B, this conditional probability, this equals to probability of A intersection B by probability of B. Okay, so from here we can get probability of A intersection B is probability of B into probability of A intersection A by B. Similarly, from second, probability of B by A equals to probability of A intersection B by probability of A. So from here we can write probability of A into probability of B by A. So this is known as multiplication rule for probability of A intersection B. If the conditional probability is given and probability of A or B is given, then you can find their intersection, probability of A intersection B, using this formula. Now we take one example that how to find the probability using this conditional definition of this conditional probability. Okay. So The question is, what is the probability what is the probability that the total of two dice will be greater than will be greater than 9 will be greater than 9 given that the first die is a 5 is a 5. What is the probability? Suppose two dice are rolling. So what is the probability that the total of two dice will be greater than 9? Given that the first die is a 5. So it is given that first die is 5. So it is the already happened event. The first die is 5.
36.
Huh?
2 by 36.
No. Actually, this is a already happened event. This is the difference between a normal probability and this conditional probability. Okay. So it is given that the first die is a 5. It is happened already. Then what is the probability that the total of two dice will be greater than 9?
Sir, 2 by 6, 1 by 3.
Yes, 1 by 3 answer. Okay, 2 by 6, 1 by 3. Because given that the first die is a 5, first die is a 5 means there are 6 outcomes. Okay, and then the total will be the greater than 9. There are only two outcomes, that is 5 comma 5 and 5 comma 6. So this is 2 by 6, that is 1 by 3. So now if you use this conditional this definition now to find this probability actually. Okay, so we define two events, that is a is the event that first die is 5 is a 5, okay? And b the event that the total is greater than 9. Greater than 9, okay? So we have to find the conditional probability. So we have to find this conditional probability. So already happened event here is a, and we have to find this total, the probability that the total of two dice is greater than 9. So this is b by a we have to find, right? Probability of b by a. So what is the definition of this? Probability of b by a is probability of a intersection b divided by probability of a. Now we have to find this probability of a and probability of a intersection b, right? So can you tell me the what are the outcomes in the event a and in the event a intersection b? First, tell me the outcomes of a.
6 by 36.
Only outcomes, not probability.
Just 6.
Yes. What are the outcomes in a? Then tell me the first outcome. 5.
Sir, 5 1, 5 2, 5 3.
Five
Yes.
one,
5
5 2,
comma
five
1.
three, five.
Yes. 5 2, 5 3. Okay. And 5 4, 5 5, and 5 comma 6. So there are 6 outcomes in A, and in A intersection B,
5556.
yes, A means first die is a 5 and B total of 2 dice is greater than 9. So A here intersection means and. Okay, so first die is a 5 and total of 2 dice is greater than 9. So only two possibilities out of these 6 outcomes, that is 5 comma 5. First die is 5 and total is greater than 9, that is 5 comma 5 and 5 comma 6. So from here you can easily find this probability of A and probability of A intersection B. Probability of A intersection B is your number of outcomes in A intersection B, that is 2, and the total number of outcome is 36. This is so this is 1 by 18, and probability of A, this is number of outcomes in A, that is 6, and total number of outcome is 36, that is 1 by 6. So this is 1 by 18 divided by 1 by 6. This is 1 by 3. This is the answer, 1 by 3. Now on relation here, so that for any three events A, B, and C, probability of A intersection B intersection C, this equals to probability of A into probability of B into probability of C by A intersection B. So that probability of A intersection B intersection C equals to probability of A plus A into probability of B by A into probability of C by A intersection B. Can you prove this? Anyone? How to prove this?
Sir, we need to start from the arranges.
सर ए इंटरसेक्शन बी को ब्रैकेट में लेंगे इंटरसेक्शन सी और फिर वो मल्टीप्लिकेशन फॉर्म.
Yes. So you can start this left hand side from left hand side. Probability of A intersection B intersection C. If you prove this if you start from the right hand side, from this side, then you can easily show this. That is just use the definition of conditional probability. But if you start from left hand side, the probability of A intersection B intersection C, see here in the last vector here C by A intersection B. So we consider A intersection B as one event. Suppose this is probability of A intersection C. The formula is probability
सर डायरेक्टली बाय आंसर.
C, yes. Probability of C and then probability of probability of A intersection B. Probability of A intersection B into probability of C by A intersection B. So again, we can write probability of A intersection B is probability of A into probability of B by A into probability of C by A intersection B. So similarly, you can prove this for AN events. probability of A1 intersection A2 intersection A3 intersection intersection AN. Suppose you have n events, then their intersection this equals to. So for three events, the formula is probability of A, then probability of B divided by the previous event. Okay. Then for three events, probability of then for probability of C divided by the intersection of previous two events. Okay. So similarly here you can write a probability of A1, then probability of B by previous events. Sorry, B means here A2. Probability of A2 by A1. Okay. Then probability of A3 by the intersection of previous two, that is A1 intersection A2. Next, probability of A4 by the intersection of previous events, that is A1 intersection A2, okay, intersection A3, this. Then dot dot. Last is probability of AN divided by the intersection of previous events, that is A1 intersection A2 dot dot intersection AN minus 1. So next, total probability law and the Bayes theorems. Using total probability law, you can write the formula of Bayes theorem. So before that, we need to know what is mutually exclusive events and a set of exhaustive events. So you have already known what is mutually exclusive events. First, mutually exclusive events. So suppose we have this n event, k event. Suppose A1, A2, up to dot dot AK. These are mutually exclusive if AI, for two events A and B are mutually exclusive, they have no common points. That is, if we find the intersection, that will be phi null event. So that AI intersection AJ, this should be phi, and this is for I not equals to J. Okay. For example, A1, if A1 intersection A3 uh, equals to phi, then A1, A3 are mutually exclusive events. And if this is hold for all K events, that is A1, A2, and AK, then we say that this A1, A2, and AK, these are mutually exclusive events. Then exhaustive events. This K events, A1, A2 up to AK, are said to be the set of exhaustive events. If we find their union, and if it is S, then we say that they are exhaustive set of events. That is A1, A2, up to AK. Events if A1 union A2 union A3, that is, if we take the union of all the events in the sample space and we get the sample space itself, that is S. Okay, A1 union A2 union A3 union dot dot union AK equals to S. Then we say that these events are set of exhaustive events. So can you give an example of mutually exclusive events and exhaustive set of events?
Sir, if when a dice is rolled, it will come even, and the second set is when a dice is rolled, it will come odd.
Yes, then they are mutually exclusive. Are they events A and B are exhaustive set of events?
Yes, sir. If the set is yeah, all the even numbers and the other set is all the odd numbers, then it is a mutual, as it exhaustive even.
Yes. Because if we take the union of odd numbers and even numbers, then we get this the whole set that is 1, 2, 3, 4, 5, 6. That is the sample space S. So if for a random experiment of rolling a dice, if you define two events, A is even number or B an odd number, then these two events A and B are mutually exclusive events as well as exhaustive set of events. Next, the law of total probability. Let A1, A2 up to AK be a collection of mutually exclusive and exhaustive events. Then, then for any other event B, any other event B in the sample space S. In the sample space S. Okay. Here is the sample space. Probability of B equals to probability of A1 into probability of B by A1 plus probability of A2 into probability of B by A2 plus dot dot plus probability of AK into probability of B by AK. Okay. And in summation form, we can write this is summation I equals to 1 to K probability of AI into probability of B by AI. So there are kth event A1, A2, and AK, and they are mutually exclusive as well as exhaustive events. Then for any other event in the sample space, any other event B in the sample space S, probability of B equals to this probability of A1 into probability of B by A1 plus probability of A2 into probability of B by A2 dot dot plus probability of AK into probability of B by AK. Now we want to prove this. So see what are the informations given here in this statement. That the first is they are exclusive and second they are exhaustive set of events. Okay. So you can yeah, by using these two informations, you can easily prove this probability of B equals to this. So given that A1, A2, and AK are collection of mutually exclusive events. So we have A1 AI intersection AJ equals to phi for I not equals to J. Okay. Also A1 union A2 union dot union AK, this equals to S, since they are exhaustive set of events, so their union is S. So these two information are given. Uh, can you write this? Uh, Now B equals to, so S is a sample space and B is the event in the sample space S, and we know that any event is a subset of the sample space. So obviously B subset of S, B is subset of S. This is clear. B is subset of S. So if B is subset of S, we can write this B equals to B intersection S, right? Since any event is subset of the sample space, so B is subset of S, and if B is subset of S, then B intersection S is the B, set B, that is smaller set B. So now S equals to, we know S equals to uh, A1 union A2 union A3 union union AK. So this equals to, this can be written as, now using the distributive law of set theory, that is, you know that A intersection B union C means A intersection B union A intersection C. Okay, so similarly apply this here. So B intersection A1 union B intersection A2 union B intersection A3, like this, union union B intersection AK. If you take, we have to find the probability of B. So if we take the probability from both sides, so this is probability of B, and probability of B equals to, the right hand side is probability of this term, right hand side. Okay. So this is the union of a set of events, that is B intersection A1, B intersection A2, and B intersection A3, and B intersection A3. So what will be this probability of the last term? This is the right hand side, probability of B intersection A1 union probability of B intersection A2.
Sir, it is the sum.
Yeah, sum of this. So why sum only?
Sir, because union is sum.
Union is sum, but there is some conditions. Not
Yes,
always.
sir. Only if it is exclusive.
Yes. If A and B are mutually exclusive events, that is, if A intersection B equals to phi. Okay. If A intersection B equals to phi, that is, if A and B are mutually exclusive event, then only probability of A union B equals to probability of A plus probability of B. And write this. So you can write you can apply this here. So before that, you have to check whether these events are mutually exclusive or not. Are these events are mutually exclusive events from B intersection A1 to B intersection AK?
Yes, sir.
So how to prove this? These events are mutually exclusive events. Okay, first tell me about this B intersection A1 and B intersection A2 only for these two events. How to show these events are mutually exclusive? B intersection A1 and B intersection A2.
We take their intersection.
Yes. we find their intersection. So if you find this B intersection A1, right, intersection B intersection A2, so this should be phi. Then we say that these two events are mutually exclusive events. So if we find this intersection, so B is common, so this is B intersection A1 intersection A2, right? And it is given that A1 and A2 are mutually exclusive events. So A1 and A2 are A1 intersection A2 equals to phi. So this is B intersection phi, since A1 intersection A2 equals to phi, it is given because these events are mutually exclusive events. Then B intersection phi. What will be B intersection phi?
Phi.
Phi, yes, null event phi. So this implies these two events, B intersection A1 and B intersection A2, are mutually exclusive events. Mutually exclusive. So similarly, from here you can say that this all these events B intersection A1, B intersection A2, and B intersection A are mutually exclusive events. So then take the probability, and you can write this is probability of B intersection A1 plus probability of B intersection A2 plus dot dot plus probability of B intersection AK. Then use the multiplication law of this intersection. This is probability of A1 into probability of B by A1. Okay. This is probability of A2 into probability of B by A2, and plus dot dot probability of AK into probability of B by AK. And in summation form we can write this is summation I equals to 1 to K. Then this is probability of AI into probability of B by AI. Bayes theorem. So to write the formula of in Bayes theorem, so we use total probability theorem, total probability law. So the assumptions that we have taken in total probability law, we also assume this here. Okay, so that is the kth event, A1, A2 up to AK. These events are mutually exclusive as well as exhaustive set of events. Okay, so let A1, A2 up to AK, these are collection of mutually exclusive and exhaustive events. exhaustive events with prior probabilities probability of AI. These probabilities are given for I equals to 1 to up to k. For I equals to 1 to up to k. Okay. Then for any other event, then for any other event b, okay, for which probability of b is greater than 0, the probability of aj, any particular event aj in the sample space S, probability of aj given that the event b had already happened is this probability of aj by b. Okay. This suppose we have a1 a k events a1 a2 up to ak. These are mutually exclusive and exhaustive events, and with prior probabilities, probability of ai. This probability will be known in advance. Then for any other event b in this sample space, and probability with probability of b greater than 0, then the probability of aj, any particular event aj, given that b has already happened, and the probability of aj by b. Okay, this is the conditional probability. So if we apply the use the definition of conditional probability, that is the probability of aj by b. So this equals to probability of aj intersection b, right, divided by probability of b. Okay, probability of aj intersection b divided by probability of b. So now using the multiplication law of this intersection, you can write this is probability of aj into probability of b by aj, right, divided by probability of b. Now we can write probability of b using this total probability law. That is probability of b equals to this summation I equals to 1 to k probability of ai into probability of b by ai. So this equals to summation I equals to 1 to k probability of ai probability of b by ai. Okay. So for the k events a1, a2, and ak, they are mutually exclusive and exhaustive set of events. Then the probability of the event aj that b has already happened. Here b is an event in the sample space. Then probability of aj by b equals to probability of aj into probability of b by aj divided by summation of I equals to 1 to k probability of ai into probability of b by ai. Okay, so in next class we will solve some problems from the exercise 2.4. So I'm taking attendance, roll number 101, 119,
So 101 present, sir.
okay, 119, 148,
Present, sir.
165, 168, 205, 207, 213,
Present, sir.
227, 229,
Present, sir.
294, 318,
Present, sir.
320, 353,
Present, sir.
479, 491, 567,
Yes, sir.
575,
Present, sir.
651,
Present, sir.
660,
Present, sir.
678, 798, 809,
Present, sir.
811,
Present, sir.
814,
Present, sir. Sir,
815,
798 present, sir. 96.
815,
Present, sir.
817,
Present, sir.
825,
Present, sir.
832, 853, 895,
Present, sir.
936,
Present, sir.
939, 957,
Present, sir.
959,
Present, sir.